Welcome back, Hampshire chemistry students. Today in this video, we're going to be taking a look at some of the basics of the atom, just as some review notes. So let's take a look here at a very simple drawing of an atom with our three main parts. We're looking at our protons, our neutrons, and our electrons. Remember that the protons and neutrons are going to exist in the center of the atom in the nucleus, while the electrons are going to be out around it in rings. Okay, we'll be talking more about those energy levels, those layers of electrons coming up later. But for right now, let's break down our basics of our protons, neutrons, electrons together, starting with our protons. So, protons, as with a name like protons, that means they have a positive charge, giving you a nice reminder. So they have that positive charge. And in the center of the nucleus, they do end up having some effect on our mass. Specifically, we measure the mass of parts of the atom in atomic mass units, or AMU. And we describe a proton as having 1 AMU. Now, their main job within the atom is that they are the thing that determines what the atom is. So, if I have 5 protons, I will always be boron. If I add one more proton, I'm no longer boron. I become the element 6, which is carbon. Now, this idea of counting our number of atoms is very simply described as the atomic number. And your atomic number will always be equal to your number of protons that exist inside of that nucleus. So let's take a look then at neutrons. These guys have some similarities, but their first big difference comes in their charge. So neutrons comes from the word neutral, meaning that these guys have no positive or no negative charges. They are neutral. Now, just like protons, you notice in my drawing, they're about the same size. That means that they're going to have about the same mass of 1 atomic mass unit. So, what is their job in the atom? Very simply, aside from adding mass, they are going to help affect the stability of an atom. So whether it will stay together or fly apart determines on the number of neutrons. Sometimes adding a neutron will make it stable, so it'll stay together. Sometimes adding a neutron will break it apart. That's something we'll learn more about when we talk about radioactivity. So, since both protons and neutrons add to the mass of our atoms, we can easily find our atomic mass by taking the number of protons plus your number of neutrons. Okay? This is a very simple equation that's going to be very important throughout the rest of this unit. So, our final step of our pieces of our atom, we have the electron. Okay? These guys are kind of the counter opposites of protons. Notice that they are around the outside of the atom, and these guys will have a negative charge to cancel out that positive from the protons. Now, these guys essentially do not add any mass to our atomic mass. Now, that does not mean they have no mass. They do have some amount of matter to them, but it is so tiny. It's much tinier than my drawing shows. A proton is about 10,000 times bigger than an electron. So essentially we say they have no mass. Now, what's important to note here is the relationship between electrons and neutral atoms, meaning atoms with no charge. If you're talking about an atom that is neutral, the number of protons will equal your number of electrons. This will help us a bunch talking about how we can describe our different atoms. So, finally, let's take a look at how we can write out some of the names of these atoms real fast. So this guy, since it has 2 protons, is definitely going to be helium. But if I'm describing one atom like this, I would best describe this as helium-4. The 4 here meaning the mass of the atom, the protons plus the neutrons. You sometimes might see it written like this, though, where it's just the symbol, He-4. It means the same thing. So, finally, we have a last type of notation, which is going to look a little bit like this, where you have the symbol for He, and then you have a 4 and a 2. So the 4 here is going to represent your atomic mass. So that's your protons plus your neutrons. whereas the 2 is very simply the atomic number, which we already know is the exact same as our number of protons. So you might also see this written one last way, and that is how it's seen on our periodic table, our P table. So this guy, again, you see the 2 in the top right. That is, again, our atomic number. But the number on the bottom here is our average atomic mass. Now, how is this different? Well, think about like an average. The averages you might have heard of. Teachers probably talk about average test scores. The way to describe this is that this atomic mass for this helium is like the grade of one student. They got a 4. Whereas this atomic mass is kind of like looking at all of the class together. So this is the average of everybody. So this is one atom's mass, and this is all helium's mass. We'll get more into the difference between those and how to calculate that coming up soon. But for right now, this is simple, the basics of atoms. I hope this has helped. Please give us a like and subscribe, and we'll see you guys coming up soon. Have a good one.